Hi, my name is AD with ACiQ, and today let's look at a 3-ton ACiQ unitary system. This is the board for the air handler. We're going to start at our L1, L2, our supply voltage. L1 obviously going to be L1, L2 obviously going to be L2, and then ground. If you measure this L1 to ground, you should get between, depending on if you have 208 or 240, you should get your line 1 voltage, and then between L2 and ground, you should get your line voltage between L2 and ground. That goes to the board, to our connector here with the red and black. We're going to go ahead and remove this and get this out of the way. So once the board has power, you've verified that there's power coming into the unit. You should verify that the power is going into the board. Once you have power going into the board, then you know that you should be getting power to your relays. So we have right here our 3-wire connection to our indoor air handler fan. And this is also controlled by DC communication on our connector here with our 3 wires, the black, orange, and blue. I'm going to go ahead and move these out of the way. Sometimes these are put together in a factory by robots, so the connectors can be stiff and hard to remove sometimes. So once we're here, we're going to move down to our thermistors. All our thermistors are right in a row here. We have a 2-pin connector, a 4-pin connector, and another 2-pin connector. We'll remove these. You'll check resistance on a thermistor. These are 10K thermistors. I'm going to set my meter to ohms. You can see that. And I'm going to check across these 2 pins. Fighting with me, one second. And you can see on this thermistor, I'm getting 11.69 K ohms. So you would match that with a chart for the ohms. It's a 10K2, and that would give you what the temperature is for what the ohms are. On the 4-pin connector, you can see you've got the 2 pins are side by side, so you will measure from, we'll say, from left to right, this connector to that connector, and then this connector to that connector. If you measure across between these, you're not going to get any resistance reading because they are not attached. And you can tell because they have sleeves that isolate each wire set from each other. So we'll check between these 2 connectors on the left-hand side. And you'll see we got 11.84 ohms, or K ohms. Then we'll check between these 2. And we've got 11.86 K ohms. So like I said before, you would take that ohm reading and you will match it against a chart, and that'll tell you if that temperature sensor is within range. And our last thermistor here, this is actually for the inlet air. We'll check across this. Now on this connector, it's going to be a little more difficult with like fatter needle probes. You're going to have to get something similar to what I have here to be able to get into that connector. But I'll check across this, and you'll see we got 11.55 K ohms. I'm going to move these out of the way. So those connectors are on the board, and you can read the location. We have T2, T2B, T2A, and T1. It's kind of difficult to see, but if you just look to the corner here, you can see each reading. Right next to each of those connectors, it also says the pin location, which is CN46, CN6, CN29, and on the last one, it is IC14. When you're checking resistance, you need to have the power off to the unit and have removed the sensor from the board. Do not test resistance with power running and at the board and at the pin locations. When you are testing DC voltage to check to see what the volts are on the pins, the power does need to be on, and the connector needs to be connected to the actual board. So we're going to move down to our electronic expansion valve. That is on CN21, and it's marked EXV. And you can see it is a 6-pin connector. Now, if you have an issue with your EEV, I suggest you call technical support and we'll walk you through the checks on that. But just so you know where it's at, it is on CN21 And we'll move this out of the way. Next, we're going to go to our communication wire between the main board and the data transfer board. That's on CN10. I'm going to pull that off. And I'll show you that is a 6-pin connector. And that's going to take us over to the data transfer board, where you'll see it's connected at the bottom, and the data transfer board is the board with the LED display. Now I'm going to step back to the main board real quick, and we're going to show you the field wiring for S1, S2 communication. If you look here on the left-hand side, and it depends on the orientation of the board to you to me. To me, it's on my bottom left, but it could be different depending on how the air handler is mounted. S1 is right here on the bottom. You can see it's CN20. And S2 is right next to it, and it is CN43. If you're using the DC communication, you want to make sure to wire to S1, S2, and do not wire 24 volts AC or low voltage to the S1, S2 terminals. If you do that, you can damage the board. So we're going to step over to the data transfer board. And if you look on the data transfer board, we have the connector CN1, which is the communication wire from the data transfer board to the main board. The wiring for the wired wall controller on DC communication is going to be HA and HB, and you'll see this yellow right here. If you look right next to it, you have these two terminals marked HA on CN3 and HB on CN7. If you're using the provided wired wall controller, you're going to wire 18.2 shielded to HA and HB to the wired wall controller. If you're using a 24 communication for the indoor air handler to the outdoor heat pump unit, you're going to wire S1 and S2 to S1 and S2 on the outdoor unit. I'm going to come up to here. And here are the dip switches. We have SW1 through 4, SW2 through 4, SW3 through 4, and SW4 through 4. We also have a set of dip switch settings over here, which is S4. And then we have our potentiometers at the top left up here. The top one is for the heat strip lockout, and the bottom potentiometer is for the compressor lockout. Those are factory set to 0. We also have this set of dip switch settings right here, 1 and 2. If you have any issue with dip switch settings or wiring, please reference our Unitary Quick Start Guide or call technical support.